Welcome back, students. I hope you have understood the previous two fundamental laws that we had done, the law of conservation and the law of constant proportion. And I hope you have solved the numericals that were given. Today we'll start with the third law, that is the law of multiple proportion, which was given by John Dalton in 1804. Now, it has been observed that in many cases, two elements combine under different conditions to form two or more compounds. Like, for example, if we take hydrogen and oxygen, two elements, and they combine together to form water as well as hydrogen peroxide. Water as H2O, hydrogen peroxide as H2O2. But the ratio of weight of hydrogen and oxygen, the ratio of their masses of hydrogen and oxygen in the two compounds is entirely different. Okay, so when we talk about the law of multiple proportion, we are concerned with two elements which have the capacity to form more than one compound. Okay, but what is seen is that in these two different compounds or more compounds, the masses of the ratio in which they combine together, the ratio of the masses in which they combine together is different. So according to law of multiple proportion, what could be the definition? When we say the definition, or what does the law state? The law states when two elements combine to form two or more compounds, then the different masses of one element, which combine with a fixed mass of the other element, bear a simple whole number ratio with one another. Once again, when two elements combine to form two or more compounds, then the different masses of one element, which combines with a fixed mass, a constant mass, a particular mass of the other element, bear a simple whole number ratio with one another. So when we are looking at, let us see for an example. Before we go into the details, let us go for an example. I have carbon and oxygen. Now, carbon and oxygen, they can form compounds carbon monoxide, that is CO, and carbon dioxide, that is CO2. And when we say carbon monoxide, carbon is one atom. So what is the mass? 12, because carbon has got atomic mass 12. Oxygen is one atom, so atomic mass 16. So the ratio of the masses of the two elements, carbon and oxygen, in carbon monoxide is 12 is to 16. When we say carbon dioxide, the ratio of the masses of the two elements, carbon and oxygen, in carbon dioxide, that would be carbon 1 atom, 12, oxygen 2 atoms. So 2 into 16, that would be 32. So the ratio over here is 12 is to 32. Now, according to the law of multiple proportion, we are supposed to keep one of the masses constant, one of the masses fixed. Now, here it is already fixed. Carbon has got atomic mass 12 in carbon monoxide. Carbon has got atomic mass 12 in carbon dioxide. So we have the same masses in terms of carbon. So let us say the mass of carbon is fixed. It's 12. Okay. And what about the masses of oxygen in the two compounds? In carbon monoxide, oxygen is 16. In carbon dioxide, oxygen is 32 in terms of mass. So what is the ratio between them? 16 is to 32. And what is 16 is to 32? 1 is to 2. Is that a simple whole number ratio? Yes. So when we say the law of multiple proportion in terms of carbon and oxygen are two elements. They are combining to give more than one compound, that is carbon monoxide, carbon dioxide. When they combine, if we are fixing the mass of one, here it is in terms of carbon, that is the same value, 12. When we fix the mass of one, the mass of the other, that is oxygen in this case, will bear a simple whole number ratio with one another, that is 16:32 in the two compounds, and that means it has got a simple whole number ratio. Let us take another example. Sulfur and oxygen. Now sulfur and oxygen means sulfur forms two compounds, sulfur dioxide and sulfur trioxide. Sulfur dioxide is SO2, sulfur trioxide SO3. In sulfur dioxide, sulfur is having atomic mass 32. Oxygen will be now 2 into 16, that is 32. So the ratio of the masses in sulfur dioxide is 32:32. And when we come to sulfur trioxide, the ratio of their masses in terms of sulfur trioxide would be 32:48. Why 48? Because 3 into 16, 3 atoms of oxygen. So 3 into 16, that becomes 48. So I have the ratio 32:48. Now we have to fix the value of 1. The mass of 1. Here it is automatically fixed. The sulfur has got 32 and 32 in both the cases. So what is the ratio between oxygen atoms in the two compounds? Oxygen in sulfur dioxide is 32. Oxygen in sulfur trioxide is 48 in terms of mass. So what is the ratio? 32:48. That will come out to be 2:3. So what will be that? That will be a simple whole number ratio. Okay, that means again I'm keeping the mass of one fixed. The mass of the other will bear a simple whole number ratio with one another. Let us take another example. Nitrogen and oxygen. Nitrogen and oxygen, they combine to give the oxides of nitrogen. And we know of 5. Okay, so we have N2O, that is nitrous oxide. What's nitrous oxide? You've heard of nitrous oxide. It's also called as laughing gas. Then you have nitric oxide, N2O3, that is nitrogen dinitrogen trioxide. Then you have N2O5, that is nitrogen pentoxide, nitrogen dioxide. So we have 5 different oxides. Let us look at the ratio of their masses. N2O is 28:16. NO would be 14:16. Why 14? Because atomic mass is 14, oxygen is 16, so 14:16. N2O3, nitrogen 2 over here, so 2 into 14, 28. 3 oxygen, so 3 into 16, 48. So ratio is 28:48. In NO2, the ratio would be 14:32 because 2 oxygen now. And in N2O5, the ratio would be 28. That is 2 for nitrogen. That means 2 into 14, 28. And 5 into 16, that is 80. So these are the ratio of their masses. N2O, 28:16. NO, 14:16. N2O3, 28:48. NO2, 14:32. And N2O5, 28:80. Now when we say we have to fix the mass of 1, what does fixing the mass of 1 mean? When we say fixing the mass of 1, fixing means, let us take for example, let us fix the mass of nitrogen in all the cases. So here we have 28, here we have 14. So I'm going to make the entire all nitrogen in all the 5 different oxides as 28. So let us convert. The first one is already there, 28:16. If I have to make 14:16 and that 14 into 28, I have to multiply by 2. So 14 into 2, 28. So I have to multiply 16 also by 2. So 16 into 2, 32. So 14:16 is 28:32. Third, we already have 28. So 28:48. Fourth, I am converting this into a constant value of 28. So this will become, the NO2 will become 28:32 into 2, that is 64. So 28:64. And N2O5 would be 28:80. That would be a constant again. It is already 28. So we have 28. Now what have we done? We have fixed the mass of nitrogen. And what do we see? In terms of oxygen in all the elements, in all the compounds, we have 16:32:48:64:80. Is that having a simple whole number ratio between them? Yes, it will come out to be 1:2:3:4:5. So did you understand? When we are fixing the value of one element, the ratio of the masses of the other element in the different compounds, they will bear a simple whole number ratio. So when two elements combine to form two or more compounds, the weights of one of the elements which combine with a fixed weight of the other will bear a simple whole number ratio. That is the law of multiple proportion. Okay. Now, when we say the law of multiple proportion, this law also has got certain limitations. Okay. Like, for example, the limitation could be if in this case nitrogen, we have different isotopes of nitrogen in the different oxides, then automatically the masses would be different. So there we will not be able to fix the value of 1. Okay. So when we have isotopic form of the particular element in the different compounds, then we cannot have the law of multiple proportion. Okay, so that ways we are not able to explain the law of multiple proportion. Otherwise, we'll be able to explain the law of multiple proportion in almost all compounds which have got such a formation in terms of the same elements. Let us take, for example, a few numericals. Okay, the first numerical which I've solved over here, tin forms 2 oxides. Okay, the percentage of tin in the 2 oxides is 78.77 and 88.12. Show that these data confirm the law of multiple proportion. Once again, tin forms 2 oxides. The percentage of tin in the 2 oxides is 78.77 and 88.12. So that means, suppose I take the mass to be 100. Okay. In one oxide, suppose the first oxide, the mass is 100. Percentage of tin in that first oxide is 78.77. That means in 100, 78.77 is tin. So how much is oxygen? 100 minus 78.77, that will become 21.23. That means 1 gram oxygen. I'm going to fix the value of oxygen. Okay. Mass of oxygen is 21.23 if I have 100 grams of the oxide. And the tin is going to 7. That means 78.77 amount of tin is going to combine with 21.23 amount of oxygen to give me the oxide. So 1 gram of oxygen will react with how much tin? It will react with 78.77 divided by 21. In unitary method, 21.23, that will give you what? That 3.7 grams of tin. So in the first case, if I take a fixed value of oxygen and that fixed mass of oxygen, I'm taking it as 1 gram. So 21.23 used to combine with 78.77 tin. So 1 gram oxygen is going to combine with how much tin? 3.7 gram of tin. Let us take the second oxide. In the second oxide, what do we have? The second oxide, mass of tin in the second oxide, also I am taking mass of oxide, I am taking it as 100 grams. And how much tin was the percentage? 88.12. So if 88.12 tin was present, how much oxygen will be there? 100 minus 88, that is 11.88 grams. So again, I'm going to fix this to 1. So 11.88 gram oxygen reacts with 88.12 gram tin. So 1 gram oxygen will react with how much? 88.12 by 11.88. So you will have the value as 7.4. That means 1 gram of oxygen over here reacted with 3.7 gram of tin. And 1 gram of oxygen here reacted with 7.4 gram of tin. What have I done? I have fixed the value of oxygen, 1 gram, 1 gram. So that means tin must have a simple ratio between them. 3.7 is to 7.4. That would become 1 is to 2. That is a simple whole number ratio. That means this data confirms the law of multiple proportion. Did you get this? A simple question. Another example. Let us take another example. Okay. Percentage of hydrogen in 3 hydrocarbons. Hydrocarbons you've studied in class 10. Compounds of hydrogen and carbon is 7.7, 14.3 and 2.5. Show that these data illustrate the law of multiple proportion. Let us write down. Percentage of hydrogen is given. So mass of hydrogen is given in all the three. In the first case, 7.7. In the second case, 14.3. In the third case, 25. It's a hydrocarbon. So the other element is what? Carbon. So if 7 percentage is given, that means suppose 100 is the total value. So 7.7 masses of hydrogen. So how much would be of carbon? 100 minus 7.7, that will become 92.3. Mass of hydrogen is 14.3. So if 14.3 is hydrogen, how much of carbon would be there? 100 minus 14.3, 85.7. And mass of hydrogen is 25, means mass of carbon is 75. Now I am going to, if 7.7 gram of hydrogen combined with 92.3 gram of carbon, 1 gram of hydrogen will combine with how much? 92.3 divided by 7.7. I'll get it as almost equal to 12. 14.3 hydrogen combines with 85.7 carbon, means how much? 1 gram of hydrogen will combine with 6 grams of carbon. And the same way, if 25 of hydrogen is combining with 75 grams of carbon, 1 gram of hydrogen will combine with 75 by 25, that is 3. So if I am fixing the mass of hydrogen as 1 gram, the mass of carbon will come out to be 12 is to 6 is to 3. And 12 is to 6 is to 3 is a simple whole number ratio of 4 is to 2 is to 1. So it follows the law of multiple proportion. Okay, so that is with respect to the law of multiple proportion. I'll be giving you numericals in the next video.